Hello everyone, welcome to Frontline Systems webinar on optimization in Analytic Solver, an overview of latest features and enhanced modeling support with an AI agent. My name is Dr. Sima Maliki. I am pleased to host this webinar and welcome you. Usually this presentation takes about 45 to 55 minutes. I think we will be using the whole 1 hour. It is interactive. You're welcome to type your questions in the GoToWebinar chat box during the presentation, and I'll try to answer all of them by end of the webinar. The goal of today's webinar is for you to gain an overall vision of the features and a few of possibilities that are available to you. There are reference materials available for you which provide in-depth knowledge and a comprehensive overview of all the features. Many industries and organizations across the globe for many decades have been using frontline system products which contributed significantly to their benefit. Analytic Solver well equips your toolkit as a confident and successful leader, analyst, researcher, or developer. Given that, today we'll focus on optimization using Analytic Solver, our all-in-one product. For now, I will start with an allocation and production modeling application in manufacturing industry. I will show you what you can do within and beyond Excel with an overview of recent and advanced capabilities of Analytic Solver. We will see how easily we can share the model and its results with others in a repeatable and manageable process using deploy options. We will also explore our AI agent for modeling support and enhancement. After that, we will focus on stochastic optimization. We'll review an agriculture application with uncertainty and use recourse decision variables and the power of stochastic optimization to make the best decisions. Analytic Solver is our all-in-one solution. This means it completely equips you to model and solve deterministic and stochastic optimization models, Monte Carlo simulation, decision trees, and decision tables. When it comes to decision trees, you have access to single-stage and multi-stage decision trees, and we are in full compliance with DMN rules. And of course, you have access to data visualization, forecasting, text mining, machine learning, and other predictive analytic capabilities for large data sets. Analytic Solver runs for Excel for Windows, Excel for Mac, and Excel for Web. It works very well with Microsoft Teams. I will show you today. And we will see that we can go beyond Excel with point-and-click deployments using Power BI, Tableau, and much more. But this is just a starting point. We offer much more products, including platforms such as Rayson Decision Services, Solver SDK, and Excel Miner SDK. We will talk briefly about Rayson today. You will get an introduction. It's a cloud platform offering decision analytics for Microsoft Cloud, and it offers a REST API. Now, Solver SDK offers developers working in C++, C#, Java, Python, or R a high-level API for prescriptive analytics, and Excel Miner SDK offers a high-level API for predictive analytics. So this was just an overall picture of product line. Now we are going to focus on Analytic Solver and its capabilities for deterministic and stochastic optimization. So this is a simple manufacturing example. We want to maximize cost of operating 3 different types of machines, Alpha 1000, 2000, and 3000, that produce only one type of product. Okay, it's pretty simple. And they have differing cost and capacity. We have a certain demand to meet, it's 750. And there are costs associated with the fixed initial and variable operating costs per product. So here are the initial costs and then additional cost per product. There are a certain number of machines available for each type, and there's a max number of products they can produce, right? So we have 8 of Alpha 1000, 5 of 2000, 3 of 3000. What do we need to do to use the solver? We need to define and determine decision variables, objective and constraints, and define them using the optimization model group. So let me show you, highlight the optimization model group. This is optimization model group that we will be using to define optimization problems. To find out your decision variables, you can ask what factors are under our control. Here we have control over how many machines to use and how many products to produce with them, given certain restrictions. I will get back to the restriction. So our variables are number of machines to use and number of products to produce using each machine. So we want to define these 3 cells for number of machines to use. This is how you define them as decisions. Go to decisions on the ribbon on the optimization group, define them as normal. And then on the task pane, this is called task pane on the right side. This is the optimization group. You can see that C7 through E7 are added as normal variables. As you may have noticed, under decisions, we also have recourse type of decisions. This is the second part of our optimization, stochastic optimization. We will talk more about using recourse decision variable. So I will come back to this one. The next group of decision variables are number of products to produce daily. Let's select the block. You can do it one by one. You could do all 6 of them together, decisions and normal. And then if you go under optimization, C8 through E8 is added. Restrictions on decision variables lead to the next component of the optimization model, constraints. To determine constraints in general, you can ask what restrictions limit our choice of decision variables. Obviously, we have some restricted availability of resources resulting in need for 2 constraints, total number of machines available to utilize and the max production limit based on how many machines are going to be used. And let's not forget, we need to meet the demand. So let's add these constraints. Total number of machines to use. So these are the machines to use. I'm going to select this block and the number of machines that are available are in this cell, right? Let me highlight this part. So let's select this number of machines to the decision variables. Go to Analytic Solver, click on Constraints. There is a drop down with 3 different group of constraints. Normal constraints that we will use now. You have access to chance constraints. This goes to stochastic optimization when there is uncertainty. And then we are going to use variable type and bounds. So let's go to normal constraints. We want to make sure number of machines used is less than or equal to. So this is the add constraint dialog. We have the left-hand side, what direction, and now we have to adjust the right-hand side. So click on this button and select max number of machines available. And as soon as you click OK, you can see that this constraint is added. Next group, number of products to produce daily. And here I calculate C17 to multiply by max number of products per machine. Okay, so it's going to be like we will have kind of variables on both sides. So select this block, go to constraint, normal constraint. It should be less than or equal to. And at this side, we have row 16, C16 through E16. Now, what else? Okay, demand. Here I calculate total production. And I want to make sure we are going to meet the demand. So let's select this cell, constraint, normal. This has to be greater than or equal to, and on the right-hand side, we put the demand, H8. We need to add some additional constraints. Since the number of machines to be used need to be a whole number, we must add integer constraints for number of machines to use. So this is how you do it. Select the block of decisions, go to constraint, variable type bound, and define them as integer. That will make sure we will get whole numbers. And this is how you will see that added under task pane, integer. Another type of constraint is non-negativity constraints. Sometimes we need to add non-negativity constraints. Let me show you how you do that. Just select the block, go to constraint, variable type bound, greater than or equal to, and then add a lower bound of 0. This is such a common occurrence. We also have an option for it under engine tab called assume non-negative. You can check that to true. So I add those. Let's add the objective. To find out the objective, you can ask what measure we are trying to optimize. Our objective here is to minimize total operational cost. I calculate in this cell using toSumProduct function, factoring initial cost and additional cost per product. So now what we can do, just select the cell, go to objective. You can see you have minimization and maximization option. Go to minimize and normal. Remember, we have expected and chance that are used when we are working with stochastic optimization or uncertainty in the model. So that's the objective. And let's go ahead and run it. And if there are problems, we'll find out together. So let's click on optimize. This is guided mode. We are going to step our way through guided mode. So I just click on optimize on the ribbon. Guided mode gives us information about the model. And let's see what it says. Continue. What is the structure of this optimization problem? This is very important. We have a linear programming or mixed integer programming model, right? It is mixed integer because we wanted to get whole numbers for our decision variables. Let's click on next step and it will solve the model. Here, solver found the solution. All constraints and optimality conditions are satisfied. So we get an optimal solution for our model. Now, in the task pane output tab, you get a log of the solution message. Okay. It tells us what engine was used. For me, it used Groby engine. Let me see why. And the reason it has done that because I accidentally check automatically select engine. Okay. So if you remove that and choose your desired engine, for example, for this one, we could just use a standard LP quadratic engine. And then you run it, it will use standard LP quadratic engine. So under engine tab of task pane, you have access to variety of engines. We have built-in solver engines and optional add-on engines. The built-in ones, for example, GRGs for solving models with nonlinear structure. LP model, quadratic models, you can solve them with the standard LP quadratic evolutionary engine. It's going to solve non-smooth type problems. It offers genetic algorithms, taboo search. You have interval global engine. It uses interval methods for deterministic global optimization. And we also have solver engines that are also commercial products. For example, Groby solver engine, Nitro solver engine. There is larger scale version of other engines available because there's some limits on the size. Mosaic, OptQuest, Express, and much more. Okay, so if you want to check out the limits, scroll down and limits are presented here. So I can use LP quadratic, the standard one, until I have 8,000 variable and constraints and 16,000 bounds. Okay, so if you go beyond that and you have a larger model, you can go to larger scale LP solver engine. And if you scroll down, the engine limits are unlimited. So you're limited only by your computational power of your machine. So this is how you define simple optimization in Excel. After you run the solver, you have access to get different reports. You can get the answer report, you can get a structure report, and much more. I want to quickly show you the AI agent, and then we can continue with what I wanted to show you with deployment options. We want to ask, for example, if you have an if function, how to linearize if function. This Analytic Solver AI technical support agent is based on the same technology as ChatGPT. It has studied thousands of pages of frontline help and user guides, everything about optimization, Monte Carlo simulation, data science, machine learning, and much more, and it's available to you to utilize. But here is the answer to what I requested. How do I linearize if function? It gives me step-by-step instructions on how to do it, how to add constraint, how do I linearize a function, and if we go down, learn more, it gives a specific reference to our user guide and exact pages to find more details. So this was an introduction to this amazing help that's available to you. Let's close this. Back to our model. Let's quickly look at another thing in the ribbon. So under model on top left, we have dimensional modeling. If you have larger models where there are multiple products, project investments, multiple time periods, multiple sources, dimensional modeling can turn a very complex problem into a simple, well-structured, easily maintained, expandable model, and it works great with pivot tables. Then we talked about optimization model group. You also have option to define multiple parameterized optimization, run sensitivity analysis, and do much more. We will talk more about this optimized dropdown we just used it for solving complete problem. Later, I will show you this option, solve for recursive variable. And if you are interested, you will learn more about analyzing transform model and solve it without integer constraints. And all of these options are available to you. So let's focus on deploy option. We use Analytic Solver, we model and solve an optimization model, we got the results, okay? How many machines to use, how many products to use, we met the demand, and we also had a lot of constraints. So now, how we can easily share our model and its results with other users in a repeatable and manageable process? Quick question. Are you sharing your model results using PowerPoint or by emailing copies of your spreadsheet? What if you change the model? Do you send a new email? So in this part of presentation, we go over the advanced capabilities of Analytic Solver to enable your model to be used wherever, whenever it is needed. And you can achieve this by using a cloud service, by calling our Raison server. Remember, we talked about Raison, another product of Frontline Systems. And the good news is that you can deploy your analytic model to the cloud, to the Raison, entirely within Excel, and even check runs of those models without leaving Excel, so no code. And with deploy option, you can turn an Excel model itself into a cloud service in seconds. So I'm just going to spend the next few minutes showing you a few of these options. Here you can host your optimization model in Microsoft Teams. First one. You can create a cloud service from your model. You can embed your model into your own application and solve it on the web or within Power BI or Tableau. This is where you can create your own application using Solver SDK, or you can create a web application with a few clicks. All these options allow you to make results conveniently available to others. This is what we call model deployment. And we're going to practice a few of these options. Let's start from Microsoft Teams. If you want to share interactive model results without sending the whole workbook, you can send a report through Microsoft Teams containing interactive links to your original workbook. And you can actually choose which part of results to include in the workbook. Now, how do we do this? Let me close this. I want to show you a few steps. Step 1, your workbook must be saved to a location that is network accessible, such as OneDrive or SharePoint. Now, this one is not saved anywhere, so if you look on the top, I'm going to turn on autosave, and then it will save it for me on Frontline Systems OneDrive. So autosave is on, and my workbook is sitting on OneDrive. It is network accessible. Now, you have to first solve the model, save the workbook, otherwise Teams won't be accessible because you want to share the results, right? So it makes sense. Let's see if it's available. Yes. But anyway, if it was grayed out, it means you have to rerun the model. So let's click on Teams report. This is the first dialog where you can select the model components to include in the Teams report. So you can click on these plus buttons to choose which variables to include, which functions to include, or whether you want to include objective. If you want to go one by one, you can do that, or you can just select this button to move everything to the right. And as soon as we click on OK, we have to wait for the next dialog. This is the Message Teams channel dialog. Here you have to choose the team and channel where you would like to share the results. I'm going to use test team, and then channel I'm going to use general. Workbook name, let's call it SEMA test report, Teams report, and message is, for example, for one of my colleagues, hi, please review the model outputs, model results. Thanks. This is the message that goes with the model, and then click on send. If you're not logged into your Teams, it will ask you to log in at this point. Otherwise, it will give you a message that the file was successfully sent to Teams. You can solve or simulate again to refresh the Teams workbook. Okay. Now we have done that, let's open Teams. And then you have to go look for the channel that you decided. I use test Teams and then general. And you can see that my message is exactly right here. This is the model and the message, hi, please review the model results. At this point, Analytic Solver automatically created a new workbook holding all of our model results. So let me go back and show that to you. It's called Optimization Teams Report. It is inserted in the workbook next to the model with all the outcomes that we selected. This workbook will also be saved online and made available to users that you want through a Teams channel that you selected. So this is how it works. And there are dynamic links, external cell references to your workbook model, and the automatically created worksheet will hold the model results. So it's like a dynamic answer report that is automatically updated when you resolve the model. Okay, let's go back to Teams now. Let's open this so you can just click on it. You have to click on Enable Content. And here are the results in Microsoft Teams. Exactly similar to the report that was generated for you on the workbook, right? Now, if a parameter changes in the original model worksheet, you have to simply resolve the optimization, then click the refresh icon, and there's no need to deploy a new Teams report. Let's go back to where we have the workbook and look here. Click on this three dots. So you can open the report in Teams itself, Excel desktop, their own PC, or it can be Excel for the web in a browser. So they're not limited to actually just opening this with Teams. Any questions about using Teams? Again, there's only need to generate the Teams report one time. And when generating a new Teams report, you must give the model a new unique name. So let's close Teams and continue with other deployment options. Now, if you're not sure what option to choose when exploring deployment, you can use Deployment Wizard. So this is Deployment Wizard and gives you information and help guide you through steps of creating and choosing multiple deployment options and when do you want to use them. Okay, so you can choose, for example, I want to run my model as a cloud service that web and mobile app can easily use. Click on next. It gives you more information what this means, and then you can get help to try it. So next, I want to show you Power BI example. So let's click on Power BI. You have two options, manage model or embed model. You can use manage model once the model is already sitting as a cloud service. This model we haven't posted as a cloud service yet. So let's use the embed model. So it does everything from scratch for us and create a custom visual in Power BI for us. You have to give it a name. For example, let's call it webinar and click on save. It's going to be a PBI Viz and click on save. Once I click save, you will be seeing two command prompt windows appear. And during this time, we are creating a custom visual and communicate with Rayson server. Model will be posted to Rayson server. And you will see that we can get the results and outcomes in Power BI. Our Excel model is being translated to Rayson modeling language and a custom visual is created. It's almost finishing up. Let me open Power BI. We are creating a custom visual. Okay. And we have to import this visual after it is completed, and that is when these two command prompts disappear and they're finishing up. There are two ways to import a custom visual to Power BI. You can go to File, Import, and Power BI Visual from File. That's one way. And another way is just to go back And under visualizations, there are these three dots. You can click on those and click on import the visual from file. And the command prompt windows have disappeared. So let's go look for webinar. I put GHGH, webinar GHGH. That's the Power BI visual. Let's click on open. And it says that visual was successfully imported into Power BI. This is a desktop version of Power BI. And you can see frontline system icons here. This is after importing the Power BI visual. So you can hover over to see the right one. This is my older one. This is the newer one. Let's click on that. Two gears appear during this time. Model is being solved on Rayson server, and then the results are returned back to Power BI for you. So final variables, objective and constraints are imported back to Power BI and results are displayed. Deploy option allows you to create a data well in Power BI which accepts input data. If you're interested in Power BI and exploring deployment further, you can watch a pre-recorded webinar on YouTube channel. So let me share the link with you. So I'm going to pause the screen for a second. This is Frontline Systems YouTube channel. So if you scroll down and then if you go under educational webinars, you can see I have different webinars on designing the best optimization models, share models and collaborate in teams, Tableau, and then this is what you want to look at. Discuss the Power BI in details and show you how you can import data directly to Power BI and run the model without using Excel and much more. And also there is a pre-recorded webinar on making best decision under risk and uncertainty. So this talks about all the aspects of dealing with stochastic optimization problems, including chance constraints and everything. So today we won't get to all of it, but there are more examples available here. Okay. So let's go back. Let's click on deploy model. How can we create a cloud service from our model? So basically we want to promote the model from this model that's created in Excel. We want to have it on the cloud. And there are two ways to do this. One is to translate the model into Rayson modeling language, which is JSON, or we can actually post Excel workbook itself. So let's click on Excel workbook, Excel model itself, give it a name. Your workbook can reside on OneDrive. So if name is okay, click on save. And during this time, the Rayson will open up. After a few minutes, you will see what's going to happen. Now, we talked about Rayson as a server. If you look here on this address bar, you see that this is Rayson.com. Rayson.com is a front-end portal to the back-end server. Rayson.com itself is an application. There are some model options. Once it loads, I have a lot of models under my account, and it has to load all of them. On the top, there are some execution options that we can, once the model is available, we can run the model, test the results. Now the model is available. You see a copy of it on Rayson.com. You can see that there's nothing translated. It's the exact Excel workbook itself. Now it is sitting on Rayson server. What was happening that was we were loading the model down here. This is the message. The output message shows you what's happening. This is the message we sent. Get HTTPS Rayson.net. This is where the server is, and this is the model ID with the name. Our Excel model is now promoted, and it is a cloud service. It is available. This is its name. It is sitting on Rayson server. You see a copy of it here, and you can, for example, request to solve it on Rayson server and get the results back here. If you are interested to see how the communication with the server is happening, it is down here. So we requested to solve the model, post solve, and we have to pass some information, and this is where we are getting the results. Results are available. So these are the decision variables, number of machines, remember, and this is the objective, I think. It's a constraint and H12. Okay, final objective. This format is called OData. The results are also available in JSON syntax. So how do we do that? Looking to the right, you can click on show results in JSON, and will show the results in JSON for you in JSON syntax. In the right side, you can see some properties of this model, what results it has, query parameter, and much more. Let's go back to Excel. Let's explore another alternative. Click on deploy model. Let's create a cloud service. This time, let's translate this Excel model to Rayson modeling language and post it to Rayson server. Okay, so same thing, except this time we are changing the Excel model and we actually translate it to code, and it will be automatically done for you. It's a JSON code. This is done already. And these are the variables. How do you define your variables? Lower and upper bound. How do you define constraints in JSON syntax? And here's the objective. If you're interested, this is a very good example of learning how to do it, or you can just use the model as automatically created for you. Same way, you can click on post solve, and it will actually solve the model for you and gets the results back. Same way, you get the results in OData, or you can get the results in JSON syntax. Last thing I want to show you with deployment options. Let's click on deploy. I want to show you how you can create a web application from this model that you have. And this is all possible because we have the Rayson server. So let's click on web page, go to quick test, web page. Immediately, Analytic Solver translate the model, Excel model into Rayson language. This is the model in JSON syntax. We saw that before. A browser opened up and displayed the newly created web application. This is the HTML web page. It has some text box and functions, and it has Rayson translation of Excel model, all embedded in JavaScript code on the web page. So you have some AJAX calls. You can make REST API calls to Rayson server. Use these endpoints. For example, you can click on solve or quick solve down here. And once the model is solved, the results are displayed here. If you want to learn more, right click and go to view page source. And here you can see the model in JSON syntax and how the communication with the server is happening. We have all the information, how you can call a function or delete the model and much more. So we created a web application from our optimization model, and just think about this. This ability in Analytic Solver plus the power of Rayson includes bypassing months of development work for you. So you just need to take this. If you want to modify the templates actually available, is shipped with examples. You can modify this template and then use this as a basis for your web or mobile application. I'm going to stop the deployment options here, and in the remaining time, I want to focus on stochastic optimization. Any questions? Let's go to help, example models, stochastic optimization example, and let's look at two-stage farmer. Before starting on this, I want to give you some general information about uncertainty. So we all have the same understanding of what we are trying to do when it comes to using recourse decision variables. This is a very unique ability in Analytic Solver. The key concept when you are dealing with uncertainty is that a certain parameter has a single known value. However, an uncertain parameter has many possible values. We call each such value a realization of the uncertainty. So in this slide, you can see I have one certain parameter and three uncertain parameters. We divide uncertainty into two general situations. In some real-world problems, we are uncertain about the value of parameter today, and we will remain uncertain about its value in the future, and we have to make decisions in the presence of this uncertainty. In other real-world problems, we are uncertain about the value of parameter today, but we will know its value with certainty at some point in the future. For example, a marketing or finance model. The competitor price or next year commodity prices or interest rates are uncertain today, but will become known at some point in the future. So what we say is that the uncertainty will be resolved at a future date, and at that date, its many possible values or realizations will be reduced to a single value. An uncertain parameter will become certain. Now, if you are dealing with uncertainty that will not be resolved, we must find values for decision variables that yield feasible or nearly feasible solution for many possible realization of the uncertainty. But on the other hand, if you are dealing with uncertainty that will be resolved at a future date, you can ask, what are the decisions that you must make here and now with presence of uncertainty before the uncertainty becomes known? And what are the decisions you can make on a wait and see basis after the uncertainty is known? We call the decision variables that we must make here and now normal or first stage variables. We call the decisions that you can make on a wait and see basis after the uncertainty is resolved, second stage or recourse. Once the optimization is performed in the first part that we don't know if there is this uncertainty is still there, when you get the answer, you will see that for a single recourse variable, it effectively represents an array of solution values. Instead of getting one answer, you get an array of solution values, one for each realization of uncertainty in the model. Later, we'll solve the model for recourse decision variables once the uncertainty is known. This is how we classify stochastic optimization problems and their solution method. There are 3 solution methods available in Analytic Solver: robust optimization, stochastic programming, and simulation optimization that can be applied to these type of problems. Again, go to solver.com, Frontline Solver YouTube channel, and then you can watch that video. I describe this in much more details. In the next 10 minutes, let's solve this stochastic optimization problem together. I have to skip a lot of details, but just to make sure you understand what's going on, there's a farmer that has 500 acres available to plant grain, corn, or sugar beets, and to sell for a profit or to use for feeding its livestock. And we have the selling price available. There's a limitation. If the sugar beets sold above 6,000 tons, it has to be sold at a lower price, but based on some agricultural requirements. So you can see there's some restrictions here for selling price. Then for feeding the cattle, he needs at least 200 tons of wheat and 240 tons of corn. And he can raise this on the farm or buy it at market. Then we also have the planting cost per acre for wheat, corn, and sugar beet. And you have the average yield per ton per acre for grain, corn, and sugar beet. So it's using the fixed yield for all 3 of them. So the farmers must decide on the amount of each crop to plant, sell, and purchase before the amount of rainfall in the season is known. Amount of rainfall is not certain, right? So it is uncertain. But we are not incorporating this uncertainty in this version of model. So what are the variables here? Number of acres to devote to grain, corn, and sugar beet. This part is a number of acres. And then we have other variables, amount of grain, corn, and sugar beet to purchase and sell. All decisions must be made here and now. This is deterministic model. We are not including any uncertainty. But in the few minutes, I'll show you how you can look at this model with a wait and see approach. We have a lot of constraints here. I'll let you review that on your own. Our objective is to maximize total profit in this cell, which is cost of production, including revenue and purchasing cost. So revenue minus those 2, right? Some of them are negative values, so it just adds up correctly. If you click on optimize, we solve the model here and now. Let's click on next, LP convex, and here are the results. Okay, problem is solved. how to use the acre available, different variables, number of sugar beets to sell is less than 6,000, and we sell some of the grain, we don't sell any corn, and this is our total profit. Now let's look at the stochastic option. We assume that in reality, the yields of the three crops are uncertain and are highly correlated with the amount of rainfall. How did we model this? We are using uniform distributions for yields of grain. For example, a uniform distribution between 2 and 3, lower and upper bound for grain, a uniform distribution between 2.4 and 3.6 for corn, and another one for sugar beet. And we assume that correlations between these three is nearly perfect. But if you want to define correlation, you can induce correlation using this correlation button on the ribbon in the simulation tab. Now, how much land should the farmer devote to each crop? As in the deterministic model, the farmer must decide on the amount of each crop to plant before the amount of rainfall in season is known. However, in this model, the decision on sale and purchase of each crop can be decided once the yields of these crops are known. So the uncertainty will be resolved over the horizon of interest when we know the amount of rainfall, for example, 6 or 7 months from now. So we can have a two-stage approach here, where the normal decisions are made at the first stage before uncertainties are resolved, and the recourse decisions are made at the second stage after they are resolved. And remember, we know that the yields of crops are uncertain and are highly correlated with the amount of rainfall. And we use a uniform distribution to represent these uncertain variables. So we have two groups of decision variables: normal decisions on planting and recourse decisions on sales and purchase to decide later. So let's look at the taskbar, model tab taskbar, and you can see that we have normal decisions D29 and F29 and recourse decisions D32 to I32. Okay, so these are normal, these are recourse. So the farmer must decide on the amount of each crop to plant before the amount of rainfall in season is known. After the rainfall, the yields are known and the farmer can make final decisions on sales and purchases of each crop. So we use D32, I32 as a recourse. Now, what do we have to do about the objective? We have the total profit, but it depends on uncertainty now. When you are dealing with uncertain models, you have to summarize the function, the uncertain function, into a single function. For example, you can use average or expected. Because we have 1,000 different objective function values based on each realization of uncertainty, right? We are running 1,000 trial. That is because it's a default value. You can change it to 10,000 or 100,000. But Solver requires the objective to be generalized into one function, and an easy way to do this is to take the mean or expected value of objective function. Okay. You can define sine mean of total profit, or you could have chosen total profit and go to objective and then maximize the expected value. It is the same thing. Maximizing expected value of total profit is the same as calculating the average profit and then using that as your objective. Okay, the different ways to do this. So we have a lot of summary statistics under results. You can use any of these, calculate the measure to summarize the objective function or constraints, and we'll talk more about this in that presentation. Okay, let's go ahead and click optimize here. This is guided mode. Click on next. Let's see what happens. Okay, let's read this message together. Analytic Solver was able to automatically transform your model with uncertainty into its stochastic programming deterministic equivalent. Okay, so we're using a stochastic programming deterministic equivalent. Click on next step. It's going to solve the model, and here are the results. The stochastic LP with recourse decisions was successfully transformed and solved with deterministic equivalent transform. Okay, and here are the results. Let's look at the normal decision variables. They have values. Objective is obvious. Constraints are satisfied. I want to show you something. Go to Tools tab on task pane. Here you can cycle through individual trials. For example, if you're dealing with a simulation, you can choose what trial to display, and then you can show, for example, if you show all trials, you can cycle through individual trials. As I change this, if you look at the workbook, you can see that the stage 2 variables, the recourse decision variables are changing. So I have 1000 realization for stage 2 variables. So normal variables have optimized values once we solve the model. However, a single recourse variable represents an array of solution values, one for each realization of the uncertainty in the model. So we can cycle through these trials. So yields of wheat, corn, and sugar beets are uncertain. We model them with uniform distribution. The default simulation trial is 1000. Therefore, you can think of uncertainties. Remember, we talked about this. Think of uncertainties as 1000 different values. Then say time passes, 6 months later, the uncertainty has become known, the amount of rainfall is known, and hence the total yields for crops are exactly known. Then you or the farmer can replace uncertain variables with those known numbers and then do a simple solve for recourse variables in the solver. And there's actually an option for this. So under optimize on the ribbon, if you use the drop down, there it's a solve for recourse variables. So once the uncertainty is resolved, you can modify the workbook and then solve for recourse variables. And instead of having 1000 realizations for uncertain variable, you can get the optimized value. I'm going to fix the yield for all 3 crops. We know the rainfall now. Hence, we can modify this uniform distribution. Remember, we are not going to change the first stage variables. It's in the past. So think about it 6 months before. We solved this optimization problem. We got the first stage variables and we plant the crop. Now after 6 months, we know the yields. We want to decide about the stage 2 variables. So how do I modify these uncertain variables? One is that you can just delete them and replace them with fixed values. If you don't want to do that, you can just actually use a control parameter. If you don't want to like erase your model, there's an option called lock, sci lock, and you can actually enter the realization of crop here. For example, this was a parameter, lower parameter was 2 and upper was 3. Let's just go with 2.5. Okay, so say that the yield was 2.5, save. Let's repeat this for lock for second one. This is 2.4 to 3.6. I just put 3, save. This is the actual yield now. I know the rainfall, we know the yields. And for the last one, for luck, let's use 20. So I replace uncertainties with certainty using a sci lock parameter, okay, control parameter, just to show you how to do it, okay? Otherwise, you could just delete it and replace it with a fixed number. Now that we have done this, we can actually solve the model. If you get lucky, the measured outcome could be exactly one of the values that was simulated, but best is to just resolve the model. So we go to optimize, solve for recourse variables. It is solved now, and the stage 2 variables are now fixed values. If I cycle through, so there's no more array of solutions. So these are the optimized results for stage 2 variables. So this was an introduction to stochastic optimization. There is much more you can do using the power of Analytic Solver. I invite you to watch that video on YouTube channel and contact me at consulting@solver.com if you have any questions. Excel would make it easier to get started with analytics. Today, we explore 2 key components to our product line: Analytic Solver and Reason Server. Remember, with one license to Analytic Solver, you can actually solve your models, either your desktop Excel, or you can use Excel for the web, Excel for Mac, and much more. With Analytic Solver plus Reason, you can promote your models to run them on Reason Cloud Service and make the results easily available to other people. You can create and test models, deploy them to the cloud as full RESTful decision services, and get reports everything without leaving Excel. And I showed you different examples. We started from model, we developed the model in Excel. We promoted the model as a cloud service in 2 different versions, Excel version and Rayzon version. We saw a copy of model in Rayzon.com. We communicated with Rayzon server. Remember, I showed you down here, there was a code to communicate, get the results from server. We solved it. We got the result in 2 different formats, JSON and OData. I also showed you how a web application can be created from a model that's on Rayzon server and easily get the results on HTML web page. We also saw that how we can work with Power BI and get the results back from Rayzon server. All of this is possible to go beyond Excel because of having access to Rayzon server, which is an Azure hosted platform. Remember that Analytic Solver offers state-of-the-art technology on stochastic programming and robust optimization, and it has the fastest performance in simulation optimization, many times faster than its competing products. And Analytic Solver delivers the unique capability to define and solve problems with wait-and-see or recourse decisions that we explored today. Regarding Rayzon, there is much more you can do. You can create multi-stage decision flows with automatic scheduling. It enables the results of analytic models to derive operational decisions. It supports rules and decision tables. And you can create multi-stage flows. This is a diagram editor that you can easily work with. It actually has a drag and drop option. So these are multiple stages of your data mining machine learning model, but you can actually have one optimization here, for example. And the results of optimization can be used in a simulation model. And then the result could be used in for example, decision table. Once you drag and drop these icons and bring models, you can actually click on this button and it will translate everything for you at the same time to JSON, so you don't need to write any code. It's only drag and drop. These abilities are yours because of power of Analytic Solver plus Rayzon, which bypass months of development work for you. Here is contact information for me and some other key members of our team. You can reach me at consulting@solver.com anytime if you have any questions. I enjoyed presenting this webinar and trust that it was helpful. You're always welcome to send your questions and comments to consulting@solver.com. We appreciate your time. Have a wonderful rest of the day. Thank you so much again for your time, and bye for now.